Let's go over another theorem. This is going to be Theorem 0.055. And it's going to say that if two lines are cut or intersected by a transversal, and a pair of alternate interior angles are congruent, then the lines are parallel. Let's draw a picture before we start with the proof. Let's say we have line L sub 1. We also have a line L sub 2. We'll have some kind of transversal, we'll just call it T. We'll have angle 1 and angle 2. And these angles are equal. Let's draw that out. It gets a little messy there, but I think you understand what it means. And we'll do the actual proof. Let's go over what we have so far. We'll say, given two lines, L sub 1 and L sub 2, cut by a transversal T, we'll assume that angle 1 and angle 2 are a pair of alternate interior angles. Then we're going to do this by a contradiction. We'll say, suppose angle 1 is congruent to angle 2, and we'll say, suppose L sub 1 is not parallel to L sub 2. Then L sub 1 intersects L sub 2 at a point P. And this is going to be the proof by contradiction part, so we'll do that in red. So they go on forever, and they intersect at some point P. And we'll say let Q and R be the points where T intersects L sub 1 and L sub 2. So we'll label those in orange because that wouldn't contradict anything, just having those points labeled. Oh, meant to do orange. having trouble getting that to backspace. So we'll call that one R, and we'll call this one Q. Then we'll say, note that angle 1 is an exterior angle to triangle PQR, and angle 2 is a remote interior angle. And we have triangle PQR because we assume these eventually intersected, so it forms a triangle. The picture looks a little funny, but it is a triangle in this case. So far, we haven't contradicted anything, but we're about to pretty soon here. And we'll say, so by the exterior angle inequality, angle 1 is greater than angle 2. But this is a contradiction. Because L sub 1 is parallel to L sub 2.